Hello and welcome to another live session on GW Prime Live. I'm delighted to have you all join us for what promises to be an insightful discussion on the critical important topic advancing infrastructure resiliency through digital transformation. As we all know, the world's infrastructure system are facing unprecedented challenges. Climate change, urbanization, and aging assets are putting immense pressure on the vital resources, threatening their resilience and sustainability. The facts speak for themselves. According to the World Bank, natural disaster caused $390 billion in direct economic losses globally in 2022, underscoring the vulnerability of our infrastructure. The American Society of Civil Engineering 2021 report card for America's infrastructure gave the nation's infrastructure an overall grade of C minus, highlighting the dire need for investment and innovation. The United Nations estimates that by 2050, two-thirds of world's population will live in cities, placing enormous strain on urban infrastructure system. In the face of these challenges, digital transformation has emerged as powerful tool for enhancing infrastructure resilience. By leveraging cutting-edge technologies like geospatial analysis, digital twin, and advanced modeling and simulation, we can gain unprecedented insights into the performance and vulnerabilities of our infrastructure assets. Today, we have the privilege of hearing from two esteemed experts who are at the forefront of this digital transformation. Our first guest, Dr. Bonnie McLean. She is a geospatial analyst at Open Source Solution for Geospatial Analysis, where she harnesses the power of geospatial data and analysis to assess the impact of natural disaster and climate change on critical infrastructure. Her work is invaluable in informing risk mitigation strategies and enhancing infrastructure resilience. Joining us, our second panelist, Mr. Hisam Gamal Ghaffar. He is the Digital Twin AEC Development Manager at ESRI Saudi Arabia. He is a pioneer in field of digital twins, leveraging cutting-edge technologies to create virtual replicas of physical infrastructure assets. This digital twin provide a powerful platform for monitoring, analysis, and optimizing infrastructure performance. Over the next 30 minutes, both panelists will share their insights, experience, and perspective on how digital transformation is revolutionizing the way we plan, design, and manage infrastructure systems, ensuring their resilience in the face of mounting challenges. So let's begin the session with opening remark from both the panelists. Mr. Hisam, would you like to go first?
Thank you, Mr. Sunal. Can you hear me?
Yeah, I can hear you. Go
Yeah,
ahead.
yeah, glad to be here today. This is not my first time with the beloved Geospatial World. I hope today everyone can get some useful information from our discussions, and we will try to share some insights. I hope the people will like it, and I'm very excited to be here today with you, Mr. Sonal, and with Dr. McLean as well.
Okay. Dr. McLean, your opening remark?
Well, I always like to begin an opening remark because I tend to have a different lens and framing for when I talk about infrastructure. So I like to define, for me, what infrastructure is, because we all think of, first out, we think of like bridges and roadways, but it's so much more than that. It's the physical and organizational structures that we need to operate our society as a whole. And yes, this does include the roads, but the buildings, the energy, which is usually my focus, and other structures that enable these societal activities. And a little more unique to the conversation is, I'm a quantitative storyteller. So what that means is I'm testing a lot of the pre-existing narratives that exist around infrastructure, sustainability, and climate justice. And I'm looking at these based on, are these within biophysical limits? So I'm looking at feasibility. Are they within existing institutional contexts? Like, is there buy-in and structural determinants? That's around viability. And then desirability around culture. Is there an impulse to change something in a community? And depending on what your lens is, I use the analysis framed as like a societal metabolism. And I like to use the city as my frame of reference.
Great. Okay. So Dr. Boni, starting with you, I would like to ask, with the increasing frequency and severity of extreme weather events, how can geospatial analysis help infrastructure stakeholder better prepare for and respond to these challenges?
Well, and this is kind of interesting too. I'm going to answer the question, but I really like the part about the digital twin because I was having the conversation about digital twins, and my friend Bill Cattle from Spark Geo, he says, well, that's another word for geospatial. We're doing that anyway. We're taking the real world environment and we're looking at it in the context. And I thought that was kind of neat that it's kind of a modern way of talking about it. But having said that, I come from the data science side, and I always used to laugh with my data science colleagues. It's like you're missing a column on your spreadsheet. You need location intelligence because having that location intelligence gives us enhanced decision making. Like we can have these comprehensive spatial insights, so we see actually what's happening, whether we're looking at a region level, the country level, the city level, even the household level. We have a different perspective and a different frame, and we're more efficient, right? We can streamline this project planning. We have this digital twin, if that's the case. We understand the maintenance processes on site. We can accelerate project delivery timelines because we are visual and we are there. Sustainability, which is kind of what I talk about. You have that comparative way of looking at a temporal analysis of something over time. We can look at how do we minimize, our impact, on the ecology of the world that we live in. And we also have a sense of resilience because if we look at where the vulnerabilities are, we can kind of go in and have more of a resilience infrastructure and a way of addressing these, like you had mentioned in the introduction. We have this unprecedented, these weather systems and these climate changes and these disasters. So, using these data-driven data sources, we can now look at big data and focus it instead of just having this big glump of data that we're all so proud of. We can now have it focused and empowered to answer some of these bigger questions.
Right, rightly said. Dr. Boni, my second question for you is what are some of the key data sources and analytical techniques used in geospatial impact assessment, and how do these tools help inform risk mitigation and resilience strategies?
Well, I mean, that's a big one. We could do like an hour right there. But what I always point back to is the innovation because we forget about this. We forget about the GPS systems, which are kind of limiting now, and they're sort of, in my opinion, aging out. That's the North America structure. But we now have these big players like GNSS, which means we can connect all over the world with all the different all the different sensors and satellites, and because it's such a large these large satellites, we can see things in real time much quicker instead of having to wait for the constant, recording and when is it going to get to that territory again in real time. So we can go like just recently, we could see ports being put in, to help people in disaster areas and in military situations. We can in real time. We can also see a lot of the mining that has created a lot of flooding events as we've eroded the dirt and things away. We have Baidu, which is the big Chinese, satellite, which is doing impeccable. It's got like double the amount of satellites that we have. So just having more eyes on the ground and to even look back too at what's changed. I mean, I've had a long, decades long career, and like the thought of being able to put these giant data sets on my computer and do analysis, using, Google Earth data and being able to see the world and bring that petabytes of data and harness it, from the cloud and answer some of these big data questions is just, insurmountable. And then you have these freely available resources, and I always start there because I'm an open source data scientist, and I use all of these data sources extensively because I teach a lot. And the last thing you want to do is to go show up at a corporate event and everyone's all fired up, like, yay, geospatial. And then they come back and they're like, wait, how much do I have to pay to bring this on board? Thank you, but no, thank you. So I like to be that alternative. And then you could always, opt for enterprise software as you develop the need and the buy-in from your organization. And I just wanted to give a hat tip to Landsat data and Sentinel data and Copernicus and all these things that we have at our fingertips. Just with a little bit of skill training, we can have this data in our offices and at our desktops as well.
Right, right. Can you also give some specific examples of how geospatial analysis has been used to assess the impacts of natural disasters and climate change on critical infrastructure assets?
Oh yeah, because we have Maxar, Umbra, some of these companies have released, disaster data for us to look at. And I remember specifically writing a story about Turkey when they had the earthquake. And it was very interesting because I was looking at all the centers that had the biggest, disaster, the biggest impact, earthquake. And I'm looking and I'm noticing that the big story was about this other area that really wasn't close to an epicenter. It wasn't reporting local damage. It was almost reduced to a single building. And the interest in this building, I think was called the Renaissance Residence, was that a powerful earthquake in southern Turkey had just demolished this building almost instantly. And using geospatial, you're able to look and see that there were these four towers that the way they collapsed and sheared off was not necessarily just because of the earthquake, because there wasn't surrounding equal damage. They were able to uncover that there was a little bit of, permit, permitting expediency for friends of the political government that compromise safety. So things like that, where you start looking at one thing and you notice patterns, and you're like, well, wait a minute, if this is a earthquake, why is this such an isolated incident of collapse? And also looking at the flooding in Pakistan. I mean, that was amazing a tragedy, but amazing to be able to go in and look at the flooding over time and see how agriculture was recovering. We had Afghan, immigrants migrating in, and they were displaced, and you could look in real time and address these. And not to mention, you can look at how a water reservoir is doing after a storm. I use it to monitor the Brazilian rainforest and look at agriculture expansion. You could actually even see poachers, because now we can look at little signals from phones. And if you're looking at an isolated part of forest, it's not a bunch of monkeys. You hit the phones. We know that there's poachers around. So I mean, there's so many applications. Volcanic. You can look at the heat dissipation from a point. You can look at power stations. I remember when Puerto Rico, Hurricane Maria, you could actually look at night and see where the lights were on and where the lights were off. Then you could also make a political narrative around, I wonder why the lights were put in this community and not this one for so long. So, it's part of that storytelling that I'm so fond of. The data's out there. Look for the patterns and, be compelled to, build out these big, important questions.
Right. Okay. Nicely pointed out, Dr. McLean. Now moving on to Mr. Hisam. So my first question for you would be, very generic, since you work for AEC sector and you utilizes that digital twin technology. So my first question is related to that only. Can you explain the concept of digital twins and how they are being applied in the infrastructure sector? And what are the key benefits of using digital twins for infrastructure asset management?
Yeah, thank you, Sonal. Actually, I wanted to learn more from Dr. McLean. What she just shared is very, very, very impressive.
Yeah.
Uh, regarding the digital twin, I also agree with Dr. McLean that the digital twin is not a new thing. It's a new thing, an old thing that we used to use without the terminology digital twin. The digital twin is just a new name to what we can call a virtual or digital replica to a real world thing, to a real world asset. It started with maybe just the equations, because I came from background of this mix of civil engineering and information technology. So I studied civil engineering. So uh, we suffered from building a simulation or a digital replica for the design before it's implemented in the real world, so we can just imagine how it will be when it's implemented, when it's on in the real life. You can imagine the cost of building a new asset, or a building, or a road, or whatever infrastructure project you are dealing with, and you just realize after building it, or during the implementation process, or during the construction process, that there is something wrong. We were supposed to make some steps to mitigate some conflict between for example, from the water utility and an old telecom utility. So the digital twins help. The digital twin technology helps the infrastructure professionals, starting from the planning, through moving to the design, the execution, and of course in the operation phase. And talking about the operation, which is the longest stage when it comes to time, uh, we need something that help us to operate our infrastructure asset to achieve the sustainability. You can imagine if we have something like an infrastructure, or a subsurface water utility, water pipeline, and there is some damage. And to know the location of this damage, we need to visit. Of course, in the first place, we need to report the damage. Then someone to make a decision to move to the location, then to search for the reason, then he can make a decision. So it takes a lot of time. Of course, there is an action will be taken, but we were talking about time. And you can imagine how much natural resource like water will be wasted in such incident. If we have a digital twin, and it has the location dimension, we can, whenever there is a damage happens in an asset, or this pipeline, water pipeline, we can make a better decision. So it also helps to make improved decision making, because we have a digital replica of this pipeline. If we have sensor or not, we can know if there is a leakage in this point. The location matters. So whenever we know there is a leakage in this point, or a damage in this point, we will define how we can move, or how we can take an action to mitigate this resource wasting. Uh, so it's about improving decision making in different stages, starting from simulations in the design phase, to have a better understanding of the real world asset before the implementation, also the operation efficiency, and by the end of the day, the most important thing for the time being is the sustainability.
Right. Nicely explained the concept of digital twin. I hope if someone who is not from the technological background, or who is no just know what the word is digital twin, but does not know how it works. If he is listening to you, he or she is listening to you, might get an understanding of how digital twin works. Okay. So now moving on, I have a second question for you, and that is, how do digital twins integrate data from various sources like sensors, building information models, geospatial data, to create a comprehensive virtual representation of physical infrastructure assets?
Uh, Thank you. Great question, actually, because the digital twin can be a lot of things, but
Right.
in the realm of infrastructure, as just
Mm-hmm.
Dr. McLean just said, that we have that geospatial infrastructure or a geospatial digital twin. So when it comes to infrastructure or the built environment, we need to have an eye view on the project, because usually the infrastructure projects are on a big scale, including buildings, including trees and subsurface infrastructure, roads, streets. So all of these information we need to make it in one aggregate model, and we need to make updates on this model. So we need to get information from different data sources. This includes the GIS, of course. It also building information modeling, as it's now the technology that is used in the information management process in the construction or infrastructure projects, and of course maybe satellite images and IoT sensor real-time feed. So we need something like a container. We can use
Mhm.
this expression, a container, to have all of these different data sources in one place. And I believe that the GIS can provide this platform. And for now, it's not, we are not talking about the future. In this moment, the GIS can contain information from these dimensioned data sources to create a comprehensive model that depicts the location, relationships, and behavior. It's not just about the visualization, it's also about having a simulation of the behavior of the assets within their environments.
Right. Okay. In your experience, what are some of the challenges and limitations associated with implementing digital twin technologies, and how can these be addressed?
Ah, okay. This is very challenging. Uh, of course, one of the most critical challenges when it comes to implementing a digital twin, of course, the cost, and creating and maintaining a digital twin can be very expensive, requiring specialized tools and expertise. And I believe to address the cost challenge, we need to be more flexible about what we really need from the digital twin. Do we need the digital twin to just to visualize something? Is this visualization thing will make a big ROI or a return on investment on me, or we can mitigate this visualization part and we can go to another way of digital twinning. So we need to be more flexible and more precise about the information or the real world asset and the target of this, creating a digital twin to the physical asset. I believe this can address the cost thing. About the challenges, I believe also the complexity, because the infrastructure projects require a lot of multiple smaller digital twins in one bigger digital twin, including all the different utilities, roads, and buildings. So I believe if we use standardization, and there is a lot of international standards now that can help us in implementing a digital twin for infrastructure projects, and also working on a standard to make the workflow more smooth between the different stakeholders inside the infrastructure project.
Right, right. Okay. My next question is for Dr. McLean. Dr. McLean, can you tell us the role of geospatial analysis in monitoring and evaluating the effectiveness of infrastructure resilience measures over time?
Well, you can think of it, but when I think of a time scale, I'm thinking of time like in different ways, and I'm thinking of the framing because we have a hierarchical scale. We have time, which is regional, right? So that if it's regional, it's different than if it's global. Something happening globally is a much different, time frame than something, happening, at the household level or at the city level. So when we think about different tools and different ways of integrating geospatial, it really has to do with the resources on the ground. It has to do with the buy-in from the team that you're working on. There's so many other things to consider that often, and I was thinking about this, um, because you can't just like implement a digital twin. You have to have buy-in. You have to have a project manager, a director, somebody that wants to engage with this. And these are all important assets to have, and the advances we have in remote sensing, for example, artificial intelligence, data analytics, all of these tools and insights aren't always available at each level, in a regional office, in a county office, in a community office. We know these things exist because we're geospatial analysts, but our job is to find the right tool at the right scale, the right hierarchy, and the right temporal solution. Sometimes you have to be able to break these down into epics, for lack of a better word. Like, what's something we can do immediately? Well, something I can do immediately might not be something that is going to, the impact is going to be felt right away. So maybe that's something that I have to look for Q2 or for next year or for 5 years out. So we have all of these advancements that are happening, and we can evaluate the effectiveness of our infrastructure if we had all these tools available. But what I always find out when we're having these discussions is talking about the latest and greatest isn't always the most relevant, because a lot of us come from like smaller communities. We come from smaller countries, developing countries, and we have major infrastructure issues. And geospatial sometimes is just somebody boots on the ground with a phone, or that can access an app offline, right? Versus somebody, swooping in with, AI and the latest and greatest, and, being able to ping the satellite and get, the latest information. And we also have to be aware too, when we're looking at the effectiveness of resilience, is looking at the cybersecurity threats and thinking about these as risks. And what I always try to tell people when I'm telling a story to a group is that, risk is not the same as uncertainty. There's things we just can't know. And you can't necessarily model those, because we can't model externalities that we don't know, right? We can't put them in the model because we're not expecting them to happen. And so then we introduce these nth order effects down the road. So I think the role of geospatial in monitoring is sometimes good, should not be the enemy of perfect. And we need to
Right.
really understand. And in data science, we talk about being able to work up a stack, up and down the stack, And it's the same for me in geospatial. Like, I could sit here and pontificate about, well, wouldn't it be great to get, this big Chinese satellite to zoom in and solve everyone's problem? But, that's not what we're dealing with, especially in these areas that are the highest risk for these climate-induced disasters. Does that answer your question?
Yeah. Yes, you answered my question very well. And I would like to ask Mr. Hisam if he can provide me example of how digital twins have been used to optimize infrastructure performance, improve maintenance and operations, or enhance resilience in face of disruptive events.
Okay, great. I believe. Thank you for the question, because I believe we're trying to simplifying very complex concepts, and an example can help in illustrating such concepts. Uh, okay. I can give an example that in a project I was part of. I was in I was working on in a consortium, British consortium. It was, I believe, Mace, Aero, Gleeds, a lot of giga construction companies in one project. The project was in Lima, Peru, the capital of Peru, because in back in 2016, late 2016, early 2017, there was a storm, a tsunami effect that caused almost that damage of almost all the infrastructure in the capital, Lima. Then we need all of these companies grouped to work on this very complex project and very challenging project. And the key to address these challenges is that creating a digital twin for the new infrastructure to mitigate what happened to the old infrastructure. So the new infrastructure will be in the same location as the old ones. So we need the new infrastructure to be resilient, to be strong enough to resist if this tsunamic effect of, or if this hazards happen again. So a digital twin contains the old weather information and the predicted weather in the same area. Also, the design from the BIM team, of course, the BIM models for the subsurface utilities, the buildings, of course, and the surrounding conditions, and as well the GIS information that provided a context for these design models to be a container for this design model. So we use the GIS as the foundation for this digital twin to contain the satellite images for the place, for the location, the BIM models, and the design for the new infrastructure, and as well information about the old weather, the historical information, and the surrounding area. So having all of these information in one place, we created what we call a digital twin, and we try to make it easy to make changes so it can be updated on a frequent basis, so it reflects the reality in almost real time. So this helped us to make simulation, to make a resilient design, so we can have a better and stronger infrastructure, because we're talking about not just natural resources and sustainability, we're talking about human lives.
Right, right. Okay. Nicely pointed out. I was, it was a very interacting session, and I was, about to ask lot more questions. But since we are running short of time, I would like to have just one more question from both of you. So, Mr. Hisam, my last question for you is, when looking ahead, how do you envision the role of digital twins evolving in context of smart cities and the increasing interconnectedness of infrastructure systems? What are the potential implications for infrastructure resilience?
Okay. Thank you for this question. Actually, digital twins will evolve to underpin the interconnection of the smart cities, uh, including real-time monitoring. And I believe this is something that happens now, but it will be more easier. It will be easier because now maybe some of the challenges that we face in the digital twin for infrastructure, as it's very complex and it has tons of data, is the data silos and the size of data. I believe the future role of the digital twin in smart cities will be having all of this data in smarter way, or more efficient way, to have a real-time monitoring and to contain all of these changes in real time in easier way. Also, predictive analysis. I believe having a digital replica and digital model can help in anticipating infrastructure needs, maintenance, and city growth trends. And of course, as the examples that I just mentioned, resilience. The digital twin can help having a resilient infrastructure, assisting cities in planning, making simulations for different planning designs, different scenarios, and adapting to to things like climate change by simulating various scenarios.
Right. Dr. Boni, as you know, Mr. Isam rightly pointed out that data is the key for utilizing any technology for bringing resiliency and sustainability in infrastructure. My last question for you is: how do you see the field of geospatial analysis evolving in coming years, and what new technologies or approaches might further enhance our ability to assess and mitigate infrastructure vulnerabilities?
Well, here's again where I'm going to explain the framing that I take, because I don't want to be reductionist, meaning I want to be a system thinker. Like I don't want to point at this, that, or the other when the driver of a lot of this is some of the upstream consequences, because we're growing in the distribution of resource extraction. So as we grow our infrastructure and our population grows, so we need to invest in the bridges and the ports and all the things and the transportation and the education. We're forcing ourselves in this ongoing socio-ecologic crisis. So we have to be looking further upstream than some of the um, ways that we've been doing. We have this Cartesian model that if we just kind of swat at little problems as they come up, they'll be okay. So we need to look at it, energy provisioning. We need to put these things on the balance sheet. There was recently an article, I think it was the New York Times, that had said if all the resource capital, the natural resource capital that we use to drive our infrastructure, drive our systems, drive the AI and the tech, if they were put on a balance sheet, nobody would make a profit. So I think we're going to start seeing, and maybe this is just my little pie in the sky dream, but I think we're going to start seeing more accountability, more indexing of these, because we're getting to that point where even transformation towards sustainable and shared infrastructure, we're going to be generating high energy demand and as well as waste. And we're going to have this sort of impact on how this is going to look moving forward. So that's kind of my conflict of interest showing up at the end of the discussion, that I I'm a human and I live on planet Earth, and I'm only one of all the species that walk this planet, and I don't want to continue extincting all the others for the sake of growth. So we just need to be more mindful and more meaningful. And I think geospatial folks are the right folks for the job. So giddy up.
Yes. Okay. Since we are running short of time, I would like to conclude the session here, and I would like to thank you both for joining in. As we bring our insightful discussion to a close, I want to express my sincere gratitude to both of you, Dr. McLean and Mr. Hisam, for sharing your valuable expertise and for perspectives on advancing infrastructure resiliency through digital transformation. Throughout the season, we have gained a deeper appreciation for powerful role that technologies like geospatial analysis and digital twins can play in enhancing our understanding of infrastructure, vulnerabilities, and optimizing asset performances. Boni is illuminating examples of how geospatial data and analysis are being used to assess the impacts of natural disasters and climate change. To Hisam's compelling insight into the transformative potential of digital twins, it is clear that we are entering a new era of infrastructure management. As we look ahead, it is imperative that we embrace these digital solutions and integrate them into our planning, design, operational frameworks. By doing so, we can proactively identify and mitigate risks, optimize resource allocation, and ensure that our critical infrastructure systems are resilient in face of mounting challenge, for extreme weather events to rapid urbanization and aging assets. However, it is important to recognize that digital transformation is not a panacea, but rather a powerful enabler that must be combined with sound governance, robust policies, and inclusive stakeholder engagement. We must ensure that the benefits of these technologies are equitable, distributed, and that no community or region is left behind in our pursuit of resilient infrastructure. Moreover, as we delve deeper into the realm of digital solution, we must remain vigilant about addressing issues of data privacy, cybersecurity, and the ethical implications of these technologies. Striking the right balance between innovation and responsible stewardship will be the critical realizing the full potential of digital transformation in advancing infrastructure resilience. As we move forward, let me build upon the momentum generated by this session and invite you all to join us at Geospatial World Forum starting from 13th May to 16th of May at Rotterdam, where we will be discussing more such thought-provoking and sector-focused sessions under Infrastructure Summit. Thank you all for your active participation and insightful contribution. See you both at Rotterdam.
Thank you, Sonal. See you there.
Yeah, thank you for joining. Bye.
Hello everyone, welcome to GW Bulletin. I'm Sachin Awana, your host for today, and here are the latest happenings. Smart Delta has entered into a partnership with Civil.ai, combining mobile mapping experience with AI expertise. Smart Delta views this step as a powerful new opportunity to address challenges and discover innovative solutions for both Smart Delta and Civil.ai clients. By joining forces, Smart Delta and Civil.ai can collectively address a wide range of issues and offer unique solutions that increase efficiency and improve decision making. Civil.ai specializes in infrastructure mapping and is known for its algorithm that can be applied for a broad range of applications. These include pavement condition assessments, traffic sign inventories, detecting asset errors, 360-degree view imagery, and LiDAR scanning of the built environment. Wireless technology and connectivity solutions firm Qualcomm Technologies has selected TomTom to deliver map data and APIs to support its Aware platform. Supported by TomTom's maps, Qualcomm said Aware will now offer transformative insights needed to mitigate risk, make more informed business decisions, and navigate challenges across industries. It will provide global asset visibility and control, providing organizations with the location awareness needed to address the challenges in a scalable and cost effective way, providing users with real time intelligence on their assets through the platform's dashboard. The EO Data Hub has announced a 3 million euro contract aimed at unlocking the potential of Earth observation data. These contracts represent a milestone in the collaboration between commercial technology providers, application developers, and data sources to deliver a first digital national EO infrastructure. The overall goal of the project is to develop and operate a new centralized software infrastructure data hub to provide a single point of access for UK and international data offerings from distributed public and commercial sources. The system provides confidence for users through access to data processing, data quality checks, and training from subject experts. Spire Global has announced the expansion of their weather and climate product suite with the launch of Spire's Advanced Soil Moisture Insight solution. Soil Moisture Insights leverages Spire's proprietary soil moisture measurement captured by the company's advanced GNSS satellite constellation, layered over the other open source space based data. Sophisticated artificial intelligence and machine learning algorithms are applied to enhance this data to deliver a comprehensive view of soil moisture around the globe. Leidos has won a potential 5-year, $206 million contract from the National Geospatial Intelligence Agency to help modernize geospatial processing. The single award, indefinite delivery, indefinite quantity contract is called MARU. It has a ceiling value of $260 million if all task orders are exercised over a 5-year period of performance. Issued as part of the agency's exploitation service program, the contract covers several relevant areas, including software development, sustainment and technology insertion, testing and user acceptance, as well as the deployment of enterprise-wide analytic capabilities. Indian space tech startup Digantara announced that it has been selected for a joint India-Australia space mission to manage debris in space. Digantara will join a clutch of space tech companies under the Space Maitri project, which recently received an INR 46 crore grant from the Australian Space Agency. As part of the collaboration, the Bengaluru-based startup will integrate its proprietary optical sensor technology into the orbital servicing vehicle developed by its partner Australian firm Space Machines Company. As per the startup, the integration will enable the monitoring of resident space objects in low Earth orbit, enhance space traffic management, and debris monitoring. In addition, another Indian space tech startup, Anand Technologies, will offer its engineering expertise and access to clean room facilities for the integration and testing. Capella Space has announced that Playrigence, a leader in artificial intelligence for geospatial data in aerospace, defense, and government institutions, as a certified analytics partner. Playrigence will leverage all-weather 24/7 SAR imagery from Capella Space to complement its advanced expertise in optical imagery analytics. Playrigence will have unique access to high-resolution SAR imagery and technical resources to develop advanced SAR-based analytics with an initial focus on the detection and classification of aircraft. Nearly a decade of geospatial AI expertise has led to the unique pre-trained AI solution capable of detecting all aircrafts in any SAR images. A second AI detector for vessels in SAR images is currently under development, also utilizing the high-quality data provided by Capella. Bay Systems has been selected by NASA to develop the atmospheric composition instrument that will fly on the National Oceanic and Atmospheric Administration's geostationary extended observation satellite constellation. GeoXO is a constellation of 3 satellites meant to expand on Earth observation made by its predecessor, NOAA's current geostationary operational environmental satellite R series. The mission will continue to gather data in support of key NOAA focus areas such as lightning mapping and visible and infrared imagery for weather monitoring. However, GeoXO will also provide novel high priority capabilities such as atmospheric composition, infrared sounding, and ocean color observation to enhance forecast and science benefits. That is all for today. See you tomorrow.